Hi everyone, Caoimhin here from CIT's Blackrock Castle Observatory. I hope that you have all had a good science week so far. In this show, we'll be taking a look at how you can test what objects in the sky are planets and how, over the course of just a week, you can confirm whether or not they are planets. So we're looking here at sunset on the 15th. We're just after 5:30, and already we have a few bright dots in the sky. In the real sky, you can figure out if something is a star or a planet by checking if they're twinkling. Stars go twinkle twinkle and planets don't. But here, the dots are just dots. You can't really tell what's twinkling and what's not. And of course, sometimes it can be tough to tell if what you're seeing is twinkling or not. So we're going to allow the sun to continue to set until we get up to about 6 o'clock, when the sky will be almost entirely dark. On the 15th, we're just at the night of the new moon, so the moon won't be in the sky tonight to interfere. As we move later in the week, the moon will begin to move across the sky. So rather than looking at Jupiter and Saturn, for this week, it's best to do this test with the red planet Mars, which is just between the east and southeast, nice and high in the sky by just 6 o'clock. So we're going to take a slightly closer look at Mars here, just a little bit. We can see that Mars is forming a nice equilateral triangle with these two other stars. If we move through just a few days, that shape will change. The moon will come into view, which can block out the stars, and of course that can make the effect a little bit tougher to notice. But once the moon is out of the way again, we can see that Mars has definitely changed position relative to those two stars. Stars in the sky remain in pretty much a fixed position. They move incredibly slowly over very long time periods. But if we look closely, the stars don't move relative to each other, but the planet will. If we make sure that Mars stays in the center of our screen, it's even easier to notice that it's changing position relative to those stars. One of the best ways to confirm this for yourself is to go outside and take a photo of Mars. And that's one of the reasons we're concentrating on Mars rather than looking at Jupiter or Saturn. Once the moon comes into view, especially if you're doing long exposure photography, the light of the moon can overtake the light that we get coming from the stars, making them much more difficult to spot. But between the 15th and the 22nd, we can certainly see that Mars's position changes relative to those stars. And if we go back out after the moon has passed, it's changed even more. This is how the ancient Greeks and Babylonians realized that the planets were different to the stars even before the invention of telescopes. They were able to see that the planets moved in a different way by observing them over long periods of time. Of course, this is even easier when you have more stars visible in the sky. Here in Cork, we have a reasonable amount of light pollution, which can make some of the stars more difficult to see. In ancient Greece, light pollution was pretty much non-existent, so we can see a lot more stars clearly here. This is what you would see just with your eyes, no need for a telescope or binoculars. We can see that Mars is making that nice triangle shape, and over the space of just a few days, it does move position. Mars goes around the sun a little bit slower than us. Its year is about twice as long as ours. So that means it's still moving through space at a reasonable speed, and we can see it changing position. The further a planet is from the sun, the longer it takes for it to move a noticeable amount. And we can see that by taking a look here at Jupiter and Saturn. So if we zoom in, the light of the moon is going to block out the stars, but we can move a few days into the future. That'll get the moon out of the way. We'll start by taking a close look at Jupiter. And it definitely moves. If we're looking at Jupiter, it almost seems like it's moving and Saturn isn't. That's just because Saturn is moving a little bit slower. It's much further from the sun, so it takes longer to get around. If we focus particularly on Saturn, we'll see that it is moving relative to the stars, but clearly Jupiter is moving a lot faster. And that's because Jupiter is closer to the sun, it's got a shorter journey to make, so it's going to travel a noticeable distance at a shorter amount of time. These are some of the ways that you can take a look in the sky and make sure that what you're looking at is a planet. Even if you don't have a telescope, even if you can't tell what's twinkling and what's not twinkling, just by observing the planets and their position relative to the stars over a few days, that's really all you need to tell if you're looking at a planet or a star. So we'll take a look at Jupiter and Saturn here. It is going to be more difficult because very early in the week the moon will come up and make those stars appear fainter. But if we just look at Jupiter here, we can see there's a couple of stars near it. Those are some of Jupiter's moons. but it moves relative to those stars, even in just a day. It's even easier when you are taking a closer look with a telescope or binoculars, but as long as you have enough stars in the sky, and even here in Cork City there's still plenty of stars visible, you can still notice that movement. It's a lot easier to notice with planets that are closer to us, such as Mars, Mercury and Venus that are even closer to the Sun. They orbit very, very quickly. So it's a noticeable jump almost every day, particularly for the planet Mercury. Its whole year is just 88 days, so it clears a good chunk of its orbit very, very quickly. If we keep looking here at Jupiter and Saturn, their relative motion will become even more apparent as we get into December, as the two planets draw incredibly close together, eventually appearing almost as one solid dot in the sky by the time we get to just after the middle of December. So Saturn and Jupiter, they are going to stay in our sky for all of Science Week, which gives us plenty of time to notice their relative motion compared to the stars. Mars as well is going to stay in our sky, not just for all of Science Week, but really the entire month and all the way into Christmas, which gives us plenty of time to see how Mars moves in the sky differently to the stars. I'm after showing you just a week, but let's very quickly take a look at just a little bit longer. We'll come back to the 15th. And we'll move all the way towards Christmas. Mars really zips across the sky once you go through that length of time. And that's because Mars, like I said, it's nice and close to us. Its orbit doesn't take it particularly long, just about twice as long as ours. Whereas the orbits of Jupiter and Saturn take decades compared to how long our Earth orbits the Sun. So again, we'll just take a quick look over a longer period of time. We can see that Saturn and Jupiter even change places. And this is because Jupiter is orbiting the Sun quicker, but also we are orbiting the Sun. And the perspective from which we're looking at those planets, it does change as we move as well. Which really just makes things easier. It's not just the planets that are moving relative to the stars, not just the planets we can see in the sky, but the planet that we're standing on. That means we're standing on a moving reference point, looking at another moving object, and all of the stars are staying still relative to us and the planets. So that can make it very, very clear, even over the course of just a few days, that those planets are moving across the sun, or moving across the stars. And this is something that you can test yourself by going outside, drawing a picture, checking with a photograph, and slowly seeing over time that the planets' positions will change. So I hope you get a chance to do that over the course of the week, and I hope it'll add to all of the other science you've been doing over the past Science Week. Thank you.